All right, everybody, we're back, and we are doing part 2. And part 1 is pretty long, so I might only show part 2, but we'll see. So we did part 1, and we found that our answer was that we're 95% confident that our mean difference blood pressure lies between 2.7 and 27.5 rounded up millimeter mercury. Okay, so now part B is asking us, drop the assumption that the population standard deviation is known. So our standard deviation here known. We're going to take that away. So let's just, just for visual purposes, that's gone. Bye-bye, buddy. And construct a 95% confidence interval from U. So we're going to do the same thing we did for A, except this time we don't know our population standard deviation. We know that when we don't know when we do know our population standard deviation, we use our Z distribution, and when we don't know, we're going to use our T distribution. And luckily for us, they were very kind to give us the sample standard deviation, okay? And it says compare the confidence intervals between A and B. So let's do B first before we can compare the two. All right, so let's do B. And from our main formula that we were using earlier, right, our known formula here, there's going to be a little bit of a difference since we were using now our T distribution versus our D distribution, okay? So let's move this, and let's take our knowns, okay? These are our knowns, and we'll go ahead and copy that. And we'll move it down here, okay? Just so that we have it again, okay? And one thing that we need, that we need for T distribution, that we don't need for Z distribution, is that we need to know our degrees of freedom. Okay, so our degrees of freedom is n minus 1, which comes out to 10 minus 1, which is 9. So that's our degrees of freedom. Okay, we've got 9. And we can go ahead and rewrite our formula here, which is our mean difference plus or minus our t-score this time. Okay, our t-score. Right, at alpha divided by 2, but this time at degrees of freedom 9, okay? And same thing here with our standard deviation n, okay? So yeah, it looks like we've got everything that we need, okay? And so let's go ahead and work through this. So we've got our mean difference d, which is we know, and we got from part 1, or in the statement above, is 15.1, plus or minus, okay, our T distribution at alpha divided by 2, which we know at a 95% confidence interval, right? We said this earlier, but we'll say it again. Oh my gosh, my pen. 95% confidence interval. I is equal to 0.05 divided by 2, or alpha divided by 2, which is equal to 0.025, and 1 minus this is equal to 0.975. Okay, so we're going to be doing our t-score at 0.975, alpha at 9 degrees of freedom. At our standard deviation sample this time, not our known, which before earlier we used 20, okay? But this time we're using our sample, which is 19.85. Okay, 19.85 over our square root of n. Okay. And so, yeah, we've got everything we need here. The only thing that we're missing here is our square root of n. Let's just put it in there, which is 10. And the only thing we're missing here is our T distribution. Okay, so just to prepare ourselves, 15.1 plus or minus. So let's go ahead and head to our T distribution table. And for a 95% confidence interval, right, where we have 5% left over here, and for that's for our two-tailed test and our one-tailed test at 2.5%, but it doesn't matter, right? We're here in this column. That's the column we're going to be in, and we're at 9 degrees of freedom, which is here on the left, okay? So just for visual purposes here, we'll go like this, and we'll go like this. And where do we meet? We are at 2.262. So let's go ahead and take our 2.2, oops, 0.262, which is at our 95% confidence interval at 9 degrees of freedom, right? And we are doing 19.85 over 10. Yeah. I guess here earlier, just to correct myself earlier, because this is what we used for the z distribution, but this one earlier is just going to be at, yeah, it's fine. It's the same thing. All right, let's go ahead and calculate this out, guys. We'll go ahead and use Desmos here. And we've got, make this bigger for everybody, 15.1. We'll do plus on this one, 2.262. And we are doing 19.85 divided by our square root of 10. And we've got on our latter half, okay, 29.29, let's go to 3, 299. And then let's do our plus or minus. Our minus is going to be 0.901. Okay. And here we go. Now that we've got those, let's go ahead and reshare our screen again. Okay. And so this is our answer here. So we are 95. Ooh. We can say that with an unknown standard deviation, population standard deviation, we're 95% confident that our mean blood pressure decrease is within the value 0.901 and 29.299. Okay, and if we're going to compare the two, right, we know that in our t-distribution, since we are working off a sample, not working off the population itself, we have to give a little bit more buffer, leeway in our two tails. So we're working with larger tails on either side of the normal distribution because of the uncertainty that we're working with since we are working off a sample. It's to account for that, okay? So that's why when working off the standard or sample standard deviation, you can see that we have a lower difference from 2.75 into 27.5, right? And seemingly more confident that it is within a lower or a closer interval of two numbers or two tails, right? Versus when we are working with our sample standard deviation, unknown population standard deviation, that we have to give ourselves a little bit of leeway and say that, yeah, we're still 95% confident, but give ourselves some buffer on either end of the tail, okay? And so to answer the question here, it says drop the assumption for the population standard deviation, which we did, compare the two confidence intervals, which we just did out loud. And so, yeah, we can say that I can just rewrite this over here later, that we're 95% confident that within or with only knowing our sample standard deviation, that our mean difference blood pressure lies between 0.901 and 29.99 or 299. Yeah, so that's number 4 for you. It's not too bad. A lot of setup, and once you kind of get set up, pretty simple. Good, easy one to start.